Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of complex numbers. And if I talk about the question that is given to us here from this topic, the question tells us let A is a set which has theta values which belong from 0 to 2 pi. And they also gave us a condition which said 1 plus 10 real number or real part of a complex number which is given to us 2 cos theta plus I sin theta divided by cos theta minus 3i sin theta is equals to 0. So that's a set given to us which belongs to A, and the question is asking us to find out summation of theta square where theta belongs to A. And if I talk about the answer choices that we have been given here, the options are 21 over 4 pi square, B, it says 6 pi square. C, it says 27 over 4 pi square. And D, it says 8 pi square. So we need to figure out which one of the answer choices is the correct answer for this question that is given to us here. Let's try to figure out how to solve this question. Before starting off with the solution for this question, I'd first like to tell you that if you are enjoying these videos that we are doing on everyday basis, please do like, share, and subscribe to my channel. Let's see how to solve this question further. So if I have this equation that says 1 plus 10 times real part of a complex number which was given to us 2 cos theta plus I sin theta divided by, it says cos theta minus 3i sin theta is equal to 0. So I have been given this entire thing. Now if I try to figure out how to solve this further, I can just take 1 on the other side and that leaves me with real part of this whole expression 2 cos theta plus I sin theta divided by cos theta minus 3i sin theta, which is 10 times, and plus 1 goes there, becomes minus 1. Dividing both sides with 10 leaves me with real part of this whole expression is minus 1 over 10. So I get real part of the whole complex number that is given to us is equal to minus 1 over 10. So I get this expression. Now let's understand this complex number. So let's say I put this as z. So z is my complex number which is given to me. That is 2 cos theta plus I sin theta divided by cos theta minus 3i sin theta. So if I have z, I know conjugate of that z would change the I to minus I. So minus I sin theta. And here because it is minus 3i, it will make it plus 3i. So plus 3i sin theta. Now we know that whenever you have a complex number, let's say z is x plus iy, and conjugate of that becomes x minus iy, where x is the real part and y is the imaginary part because it is with I. The sum of the two gives you imaginary part cancelled and this real part becomes double, so 2x. So basically I get from this here that z plus z bar is nothing but 2 times whatever is your real part of this complex number. So basically real part of this z. So we already know that real part of this whole expression, we already know that is equal to minus 1 over 10. So I get from this that z plus this conjugate of z is 2 times minus 1 over 10. And if I put this z and z bar, which is conjugate of z, I have z as my complex number, which is 2 cos theta plus I sin theta over cos theta minus 3i sin theta. Plus conjugate of that, I'm adding, so 2 cos theta minus I sin theta is over cos theta plus 3i sin theta is equal to 2 times minus 1 over 10, which is minus 1 over 5. So what I get from here now, let's try to solve this expression. So I have just used that real part of z which was given to us in the question, which was minus 1 over 10. I've used that with this expression. That adding a complex number and its conjugate gives me 2 times the real part of that complex number. So if I use that, now if I just cross multiply, I get from here 2 cos theta plus I sin theta gets multiplied with this and this with this. So 2 cos theta plus I sin theta multiplied with cos theta plus 3I sin theta plus 2 cos theta minus I sin theta multiplied with cos theta minus 3I sin theta. Dividing the whole thing with cos theta minus 3I sin theta and cos theta plus 3I sin. So denominator, I'm just multiplying the two of them because I have a common denominator now, and it is equal to negative 1 over 5 as it is. So let's try to simplify this. So if I try to simplify the two brackets, I get from here 2 cos square theta. 2 cos theta gets multiplied with 3I sin theta. That leaves me with 6I sin theta cos theta plus I sin theta cos theta, and 3I square, which is minus 3 sine square theta. Now, plus, if I multiply these two brackets also, it gives me 2 cos square theta minus 6I sine theta cos theta minus I sine theta cos theta and plus 3I square sine square theta, and I square we know again it is minus 1, so it makes it minus 3 sine square theta. The whole thing divided by a minus b, a plus b, so a square, so cos square theta minus b square. So b square means 3I sine theta the whole square, which is 9I square sine square theta. So I get this whole expression, and that's equals to negative 1 over 5. I have this whole thing. Now let's try to eliminate what I can. So I can see 6I sin theta cos theta can be cancelled with minus 6I sin theta cos theta. I sin theta cos theta can be cancelled with minus I sin theta cos theta. So from here I have 2 cos square theta plus 2 cos square theta. That leaves me with 4 cos square theta minus 3 sin square theta minus 3 sin square theta. That leaves me with minus 6 sin square theta. The whole thing divided by cos square theta minus 9I square. I square is minus 1, so plus 9 sine square theta is equal to minus 1 over 5. So if I take that 5 on this side and this whole thing on this side, so 5 times 4 cos square theta minus 6 sine square theta is equals to minus 1 cos square theta plus 9 sine square theta. So from here I get 20 cos square theta minus 30 sine square theta equals minus cos square theta minus 9 sine square theta. So from here I get this as 20 cos square theta minus comes here becomes plus 1, so 21 cos square theta, and this goes here and gives me 30 sine square theta minus 9 sine square theta, so 21 sine square theta. So from here if I see, I get 21 cos square theta minus 21 sine square theta equals 0. 21 taken common leaves me with cos square theta minus sine square theta equals 0. And we know already cos square theta minus sine square theta from the double angle formula. It is nothing but cos 2 theta. So cos square theta minus sine square theta. I can just replace this with cos 2 theta. So from here I get 21 cos 2 theta equals 0. That leaves me with cos 2 theta being 0. And that, if I talk about the angles where I get cos of something equals 0, the question says that you have to go for the theta from 0 to 2 pi. So I have 2 theta, then it can go from 0 to 4 pi. So let's go for 2 theta and let's find out where does the cos becomes 0 from 0 to 4 pi. So pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So all the odd multiples of pi over 2 give you cos function as 0. So that leaves me with theta being pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So I get the values of this theta by just dividing everything with 2. So I get all the angles of theta for between 0 to 2 pi, which the question tells us, from pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now the question tells me to find summation of all of these values of theta that I can have which belong to this set of A. I have to square them and add them. So let's square them and add them. So summation of theta square, if I find pi over 4 square, 3 pi over 4 square, 5 pi over 4 squared, and 7 pi over 4 squared. That whole thing gives me pi square over 16, 9 pi square over 16. 5 pi gives you 25, so 25 pi square over 16 and 49 pi square over 16. So that leaves me with pi square over 16, and the addition of that gives me 49 plus 25, 74 plus 983 plus 184. So 84 pi square over 16. So if I try to cancel it with 4s, 4 times and 421 times, I get 21 over 4 pi square. So I get the answer to this question that was asked to us, and that 21 over 4 pi square matches with option A. So A becomes the correct answer for this question that was given to us here. I hope you have understood how to solve this type of questions, which deals with ideas of using the concepts of complex numbers. So what we did here was it said to us expression. I solved that equation and got real part of the complex number that was given to us becomes minus 1 over 10. Then I just use the concept that if I add a complex number and its conjugate, it gives me 2 times the real part of that complex number. So that if I solve for, I get the value and the expression for theta that gives me 4 angles of theta, which comes from 0 to 2 pi, which satisfies this condition. And if I find summation of theta square, I square all of them and add them. That leaves me with the answer 21 over 4 pi square. That basically matches with answer choice A. So A becomes the correct answer for this question that was given to us here. I hope you have understood how to solve this question. I'll see you again tomorrow with some other question from some other topic. And we are going to continue this series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like, share, comment, and subscribe to my channel. I'll see you again tomorrow with some other video. Thank you.